Have you ever considered that Earth is just one member of a vast cosmic family in our stellar neighborhood? The planets are so different that sometimes it seems as if they come from different worlds. The gas giant Jupiter and the scorching Mercury, the hospitable Earth and the poisonous Venus, and yet they are all connected by the invisible threads of the solar system. Today we will embark on an amazing journey through these distant and mysterious worlds. We will see how the Japanese probe Akatsuki unveils the secrets of the hellish Venus, and how New Horizons reveals the frozen and mysterious Pluto. And finally, we will peer into the abyss of the event horizon of a black hole, where the laws of physics seem powerless. Buckle up, today's space will show us unexpected and shocking secrets. Planet Earth belongs to a group of celestial bodies orbiting around their parent star. The brothers and sisters in this cosmic family are so different from each other that there are serious doubts about their close relationship. Judge for yourself. It's hard to find similarities between the giant gas planet Jupiter and the scorching Mercury or the hospitable Venus. And yet these planets belong to the vast conglomerate known as the solar system. At various times, interplanetary spacecraft have been sent to many of them by Earthlings. Some probes landed on the surfaces of celestial bodies, while others flew by, gathering information. For example, the cloudy Venus was explored by several spacecraft, Venera, 1 Vega, Mariner, Magellan, and others. But the most important contribution to the study of this gigantic death trap, which drenches its scorching mountains and valleys with concentrated sulfuric acid, was made by the Japanese probe Akatsuki. However, even before that, the spacecraft mentioned earlier dispelled the myth of the supposedly paradise-like groves densely covering the slopes of Venus. But the Japanese Aerospace Exploration Agency's spacecraft revolutionized humanity's understanding of this hellish and absolutely lifeless world by taking a closer look at it. But the launch of the project by the Land of the Rising Sun was not very smooth at first. The mission encountered a number of problems, which delayed its implementation by a whole 5 years. The spacecraft launched from the Tanegashima Space Center in May 2010, but only entered Venus's orbit in 2015. Despite this, Akatsuki sent a wealth of valuable photographs and scientific data back to Earth, which greatly refined our understanding of the mysterious and strange planet. For a while, the spacecraft became the only artificial satellite of Venus, since, as we know, the celestial body never acquired any natural companions. So why didn't the probe land on the planet's surface? The answer is simple. The conditions there are so unfavorable that scientists are not yet able to build a rover durable enough, one capable of moving across Venus, or even surviving its suffocating atmosphere, which burns and destroys anything that falls into its deadly grip. What can be said about Akatsuki itself? It is a spacecraft weighing 640 kilograms. 34 of which are useful payload. The probe is equipped with solar panels that supply it with energy, and the eyes of the spacecraft are the IR-1 and IR-2 cameras, along with 3 lightning detectors, 2 long-wave and 1 ultraviolet. The first 2, in December 2016, unexpectedly began to consume an increased amount of energy, which greatly puzzled Japanese cyberneticists. Scientists could not understand the reasons for this sudden surge for a long time, and eventually had to turn off the cameras. Over time, everything became clear. The cause of the device's malfunction turned out to be quite simple. Powerful cosmic radiation was impacting the probe, causing part of its hardware to fail. So, was Akatsuki's difficult samurai journey in vain, and was the $210 million invested in the mission for nothing? Years of planetary reconnaissance activities have shown that no, all the efforts made were meaningful. First and foremost, the probe's main target was Venus's multi-kilometer thick atmosphere. But first, let's ask ourselves, what did we know about Venus after decades of meticulous remote research? We know that the planet is much closer to the Sun than Earth at a distance of 108 million kilometers. Venus is very similar in size to Earth, and a year on Venus lasts almost 225 days. The planet rotates in the opposite direction, making it a remarkable exception to the cosmic rules. But, as already mentioned, within the mission, astronomers were especially interested in the atmosphere of Venus, which is the densest among those surrounding other celestial bodies in the solar system. It is precisely because of this that the pressure on the planet is 92 times higher than on Earth. The Akatsuki probe, while in Venusian orbit, was the first to capture the planet's atmospheric layer in the ultraviolet and infrared ranges. Detailed examination of the cloud structure in photos of Venus's night side shows reflected waves from clouds located approximately at the distance,
55 километров от поверхности планеты.
where dark areas are noted. The atmospheric layer is densest in the next photo, taken in the ultraviolet range where sulfurous clouds can be seen falling onto the surface of Venus as deadly rains. We're used to rain on Earth drumming pleasantly on windowsills and roofs. On Venus, you'll have to forget about that. Here, a drop of sulfur dioxide combined with water vapor, after repeatedly striking the rocks, can probably produce only a vicious hissing sound. If you add the overpowering stench of hydrogen sulfide to this, the picture becomes quite repulsive. Unfortunately, the impenetrable clouds of sulfuric acid don't allow us to see what's beneath them. The atmosphere of Venus is not only monstrously hot. Near the surface, its temperature is plus 467 degrees Celsius, but also quite turbulent. This fact is proven by the following image taken by the Akatsuki probe. In it, you can see V-shaped lines caused by strong winds near the equator, while at the pole, there is relative calm. This is indicated by the smooth polar region, which sharply contrasts with the bands located below. The restless and turbulent atmosphere of Venus, caused by active convection processes and significant contributions of solar heat, is clearly visible in this image. If you're looking for sensational science, here you go. Venusian clouds have their own mysteries as well. In the next photo, you can clearly see the mysterious dark substance present in the planet's atmosphere, which actively absorbs ultraviolet light. This image was taken during the 13th orbital pass of the Akatsuki probe, and the nature of the strange substance has not yet been determined. The Japanese interplanetary station also provided strong evidence that the planet itself, shrouded in a thick blanket of clouds, is more like a deadly furnace. In the image taken in the infrared range, bright areas can be seen, indicating the hottest regions. The heat emitted by the lower layers is trapped by the upper cloud belt, creating a powerful greenhouse effect. By the way, why is Venus so hot? After all, it's not right next to the Sun like Mercury, but the planet is much hotter than its smaller neighbor. It is believed that millions of years ago, Venus was similar to our planet, but for some reason, it became extremely hot, and its oceans, which were like Earth's, completely evaporated, leaving behind bare rocks and waterless plains. The journey of the brave Akatsuki continues, but no one knows how much longer it will last.
Вы по-прежнему считаете...
If you think your grandmother's village or country house outside the city is in the middle of nowhere, then I'm afraid I have to disappoint you. There are places in the universe that are much more remote and dangerous. Not even the lifeless Atacama Desert in Chile, with its wild temperature swings and complete lack of rainfall, can compare to them. Neither the lonely Antarctic Vostok Station, where the cold reaches a critical low of minus 89 degrees Celsius, nor the Mariana Trench in the Pacific Ocean, with pressure 1,000 times greater than on Earth's surface, can compare. Get ready for the most amazing video journey of your life, a flight to the planet Pluto. To reach this insanely distant location, it will take at least 9 years, including gravitational maneuvers for acceleration. You want to talk about it, no problem. The most famous of the trans-Neptunian objects in the solar system is eagerly awaiting you. Since Pluto, at the farthest point of its orbit, is 7.4 billion kilometers from Earth, it's quite difficult to see this world clearly. The only probe that has approached Pluto is the New Horizons spacecraft, launched in 2006. It approached the object and its moons in 2015 and immediately began actively gathering information and photographing the planet. Thanks to New Horizons, the boundaries of our knowledge about the celestial body cast to the outskirts of the solar system have expanded significantly, even though close-up observations of the planet lasted only 9 days. Due to Pluto's remoteness, we knew so little about it that almost all the information from New Horizons caused genuine surprise. In old astronomy books, the planet was described briefly. Pluto is an object 3 times smaller than our moon, resembling a chunk of iceberg lost in space. That's basically all there was. Now the situation has changed dramatically. The main objectives of the probe were mapping the terrain, studying the planetary atmosphere, and creating temperature charts. And it handled all these tasks perfectly, since it was packed to the brim with useful equipment. For example, the same amount of information about Mars had to be collected over the course of 5 missions. So what would we see? Approaching Pluto and landing on its surface, the first thing a traveler encounters on the planet is Pluto's atmosphere. It is extremely thin, about the same as at an altitude of 80 kilometers above Earth. But its presence creates winds, clouds, and envelopes the planet in fog. The atmosphere consists mainly of nitrogen, methane, and carbon monoxide, but the probe also added nitrates and hydrocarbonates to this list. Unfortunately, by the time the next expedition is organized, there may be no atmospheric layers left on Pluto. It is steadily escaping into space, but for now, it is still possible to observe incredible sunrises and sunsets that vaguely resemble those on Earth. Take a look and remember how the New Horizons spacecraft saw the dwarf planet. If a spacecraft or a tourist were to land on Pluto's surface, they would hardly feel any gravity, since the mass of the object is 6 times less than that of the Moon. And in terms of volume, the planet is only slightly larger than the territory of the Russian Federation. The New Horizons spacecraft determined the exact diameter of the celestial body to be 2,376.6 kilometers. The pressure here is minimal and is only 1 Pascal. But for a traveler, there is a major problem: the extreme cold, approaching absolute zero. On the surface of Pluto, the temperature reaches -223 degrees Celsius. You can warm up a bit in the atmosphere, where it's 40 degrees warmer due to a weak greenhouse effect. The most important discovery of the mission is Pluto's tectonic activity, since it's still impossible to deliver a sample of planetary soil to Earth laboratories. We have to count the number of craters. The more there are, the older the surface is. This effect can be compared to a sheet of paper left out in the rain. The longer it's there, the more drops will fall on it. Most of Pluto is covered in craters, but there are vast areas almost free of scars left by meteorites. This fact suggests that the planet's glaciers are actively renewing themselves. But what is the terrain of this frozen celestial body like? Tourists will be amazed by 2 locations on Pluto, Tombaugh Regio and Sputnik Planitia. An Earth probe first discovered them and examined them in detail in 2015. The first region looks like a huge heart, about 2,300 kilometers in size. It was named after Clyde Tombaugh, the discoverer of Pluto, whose ashes, among other things, are on board New Horizons. In this strange region, the landscape is made up of frozen nitrogen ice, interspersed with mountain ranges. up to 3.5 kilometers high. Sputnik Planitia is another amazing feature, a basin about 1,500 kilometers in diameter. The probe saw it as silent, snow-white, without a single crater, covered with a relatively young nitrogen-methane glacier and grooves of unknown origin. The equipment of the interplanetary station determined the age of the plane to be about 100 million years, while the planet itself is over 4 billion years old. What other features on Pluto deserve attention? First of all, it's the ice covering the planet. Here it exists in 5 different phases, which can only be achieved artificially on Earth. For example, Ice 2 appears at temperatures from -63 to -83 degrees Celsius. Combined with a pressure of 300 megapascals, and when heated to -23 degrees Celsius, while maintaining the same compression, it turns into an unusually dense Ice 3. If you increase the pressure to 500 megapascals and raise the temperature by another 3 degrees, you'll get solid diamond-like Ice 5, which only melts at temperatures of +50 degrees Celsius and above. So, on Pluto, all 5 of these anomalous phases, from our point of view, are present. This durable natural material, which has no earthly analogs, forms the dunes, cliffs, and vast fields here, covered with half-kilometer-high ice crystals. Sometimes the ice thaws and instantly begins to evaporate, skipping the liquid stage. Astronomers suggest that Pluto is currently undergoing climate changes, similar to what Earth experienced millions of years ago. If the New Horizons probe flew at the same distance over any city on our planet, it would not only be able to create detailed topographic maps, but could literally count the houses. That is why research and photos obtained with telescopes are extremely unreliable. Through the eyes of the interplanetary station, we saw hundreds of times more, but the feeling of incompleteness remained. Therefore, while the spacecraft, having passed by Ultima Thule, heads deeper into the Kuiper Belt, even more advanced missions to Pluto are being organized. The more video material I create on space topics, the more I am amazed by the complexity and mystery of the laws of the universe. Answer a simple question. Is it possible to look beyond the horizon? Of course, because if you just walk a little further, you'll see what's hidden beyond it. And on the Little Prince's planet, it's even easier to do if you want to. On asteroid B612, you can watch sunsets several dozen times a day. All you have to do is move your chair closer to the horizon. But the phenomenon we're going to talk about now doesn't belong to the category of easily overcome obstacles. In fact, it's impossible to overcome. We're going to talk about the event horizon of a black hole. Let's start with the terminology. What is an event horizon? It's a 3-dimensional hypersurface that surrounds the vicinity of the cosmic monster. This imaginary line can rightly be called the point of no return or a one-way ticket, because everything that lies beyond this boundary is lost to the observer forever. Even superfast photons of light. An object or living being that gets caught in this hellish vortex will sooner or later reach the point of singularity at the very center of the black hole. But by the time it reaches the final point, the object will most likely not remain intact. It will be torn apart beforehand. An incredible absolute force of attraction, unmatched anywhere else in the universe. Why do we think there's a singularity there when in fact we don't really know what's inside a black hole? This information is classified by nature itself and protected by barriers of relentless physical laws. But humanity continues to speculate, and a journey beyond the event horizon and back would help confirm these theories. Is it possible? First, let's find out where black holes come from. Astrophysicists know this for sure. Massive stars that live a life that's too fast by cosmic standards eventually turn into these massive formations. Who can be considered real candidates for the title of future black holes? This star burns its fuel over tens of millions, not billions of years, and combines several hundred solar masses. When the hydrogen supply runs out, megatons of stellar matter instantly collapse under the force of hellish gravity, burning up like torches. Stars produce unimaginable bursts and compress so much that the particles making up the former stars literally merge into each other. Some of them become neutron stars, but especially dense and massive objects turn into the invisible monsters of the universe. They are so massive that they literally fall through the fabric of space, creating a depression or a funnel. Theoretically, any object can become a black hole, even the sun or the Earth. For example, in order for our planet to turn into an invisible magnet, its radius would have to be just 1 centimeter while keeping the same mass. And for the sun, this figure would be 3 kilometers. The critical compression of an object is called the Schwarzschild radius. And now, returning to the question posed at the beginning of the video, let's ask once again, is it possible to escape the inhospitable embrace of black holes? Physics is adamant on this issue. In order to break away from any object, you need to reach a certain speed. The escape velocity for Earth is 11 kilometers per second. For the Sun, it's 617.7 kilometers per second. And for a black hole, the escape velocity exceeds the speed of light. And as we know, it's impossible to achieve that. So it turns out we have to end the conversation since it's impossible to leave the event horizon. We should probably leave it at that, but since we're persistent people, let's try to dig a little deeper. What if we try tying an object to the ship with an incredibly strong cable and lower it into the pitch black darkness of the black hole, or use an elevator for this purpose? Would it be possible to pull the object back out, like a ship's line from the ocean depths? It seems simple enough, right? It would dip in, explore the vastness of the cosmic trap, and finally satisfy humanity's burning curiosity? Sorry to disappoint you, but not in this universe. The most likely scenario in this situation is gradual spaghettification and being pulled into the darkness of the hole, not only for the object attached to the cable, but for the ship itself as well. And all of this will inevitably rush toward the Holy of Holies, the region of singularity, the point of beginning and end of everything. At the same time, the size of the funnel doesn't matter. The principle of no return is the same for all types of holes. But what would happen if a person standing right at the edge of the event horizon tried to dip just a hand or a foot into the terrifying funnel? You might think you could instantly pull it back, but as we've already said, whatever falls into the clutches of the hole never comes back. All that's left is to hope for the mercy of a nearby astronaut who would cut off the brave person's limb before they're completely sucked in. But what about the optimistic statement by Stephen Hawking, who urged us not to give up, claiming that even from this cosmic coffin, there is a way out? It exists, but it's not at all what we would like it to be. The fact that might offer a bit of comfort to someone who has fallen into a black hole is that it isn't eternal. Thanks to quantum physics, the lifespan of deadly information is enormous, but everything comes to an end eventually. However, it's important to keep in mind that the event horizon will exist until the very last milliseconds of the black hole's life, right up to the moment when its mass becomes zero. And this is when liberation will occur. Stephen Hawking claimed that in the final hours of a black hole's decay, the funnel gets rid of excess information. It spits out jewels in the form of radiation, and the power of the cosmic monster's death cry can reach up to 5 million megatons in TNT equivalent. The information that the hole will emit during its agony includes that which contains data about the objects that have ever fallen into the monster's belly. This can be compared to urns. Ash holds fragments of information about the person who was burned, but they're no longer of any use. Although, from a physics standpoint, this extravagant explanation resolves the paradox of energy transformation and its immortality, it's a pity that there's no one to admire such an impressive event, because by that time there won't be a single star or any other source of light left in the universe. If at the moment of the death of the last black hole, you were there to witness it, the sight would be breathtaking. Amidst the utter darkness and emptiness lasting for 10 to the power of 100 years, there would suddenly be a dazzling flash, the last ray of light in the cosmos. And then the silent explosion of the black trap will finally release those who once recklessly fell into its grasp. So there is a way out of the embrace of a black hole after all, but information about it is of little practical use to us. Although it is vivid and interesting for creating imaginary pictures, the conclusion is obvious. Humanity has not yet armed itself with sufficient knowledge or improved its technology. It's better not to approach black holes, but to admire these frightening objects from afar using eyepieces and telescopes. If you disagree with the conclusions made by astrophysicists, don't hesitate to counter them. Perhaps you'll find a solution that others have missed. The price for this episode is small, just a like and a subscription. Who hasn't done it yet? Keep in mind, the Hubble channel is a live portal with regularly updated content and feedback. Stagnation isn't our style.